Alright guys, we're going to continue with our notes on chapter 3, and now we're going to start talking about the math involved with all the atoms that we've been learning about. Now the first thing that we need to know, we need to write down that the atomic number is the number of protons. The symbol for it is going to be Z, and we're going to use this throughout the PowerPoint. Now the atomic number is of course the number of the protons, but all atoms of the same element have the same atomic number. Okay? The periodic table is organized by the number of protons, so it's organized by the atomic number. Now, the mass number is the sum of the particles in the nucleus. We know that the nucleus is comprised of protons and neutrons. So, the mass number is the sum of the protons and neutrons. And we can see that here. The symbol for the mass number is A, just a capital A. Now, an isotope is an atom of the same element with different numbers of neutrons. Okay, we cannot change the number of protons, but we can change the number of neutrons. If we look for an example here, we have an example of carbon-12, carbon-13, and carbon-14. Now, the blue dots are the protons, the red dots are the neutrons, and the yellow dots are the electrons. So in the nucleus, we see that carbon-12 has 6 protons, and it also has 6 neutrons. Now in carbon-13, we cannot change the number of protons, so the number of protons is still the same. It's 6. But we've added a neutron, so the number of neutrons is 7. In carbon-14, we still have 6 protons, but again they change the number of neutrons to 8. So the difference in these three are the number of neutrons. The same thing in common, that they have all the same number of protons. Now, when we designate isotopes, there's 2 ways that we can designate them. We can either use hyphen notation, which in hyphen notation we write the name or the symbol and then the mass number that follows it. So for an example, just like from the last slide, we had carbon-13. 13 is the mass number, carbon is the element. Now, the next way that we can designate an isotope is through nuclear symbol notation. Now, nuclear symbol notation, what it is we'll put the mass number on top, the atomic number on bottom, and the chemical symbol beside it. So, carbon-13 would be written 13, because that's the mass number, over 6, because that is the atomic number, and the symbol for carbon, which is C. Some examples of this. Now in this example, it says we have 7 protons and 8 neutrons. So we look on the periodic table, and we look at the element that has the atomic number of 7. Because remember, the atomic number is the number of protons. And we see that that is nitrogen. So to write it in hyphen notation, we would write nitrogen, and then we have to use the mass number, so 7 plus 8 would give us 15. Nuclear symbol notation, we would write the mass number, 15, all over the atomic number of 7, and the symbol N for nitrogen. Another example would be number 2. It says that we have 17 electrons and 19 neutrons. Now in the previous slide we said that in a neutral atom, the number of protons equals the number of electrons. So therefore, we have 17 electrons. We know that we have 17 protons. So we look on the periodic table, the atomic number 17, and we have chlorine. So first, we write chlorine, and then the mass number, so 17 plus 19, would give us 36. So we would have chlorine 36. Then, to write it in nuclear symbol notation, we would just write 36 all over 17 and Cl for chlorine. Now, 2 more examples. This one tells us that we have Z. Z is the symbol for the atomic number. So we can go ahead this one, look at the periodic table. Atomic number 5 goes with boron. So we would add 5 plus 6, get our mass number, and then we would have boron 11. Write it in nuclear symbol notation, 11 all over 5, B. And our last example, it gives us A. Remember that A is the mass number. Now, it also gives us neutrons, but that doesn't help us figure out what the element is. So, we know that the mass number is the number of protons plus neutrons. Well, all we have to do is subtract neutrons, and we'll know what element we have, because we'll have protons. So 75 minus 42 gives us 33. So that's arsenic. So arsenic, 75, will be our hyphen notation. And then we put 75 all over 33, AS for arsenic. Now, here we have the hyphen notation, and it wants us to figure out the number of protons, neutrons, electrons, atomic number, and mass number. So on carbon 13, we know that 13, since it's written hyphen notation, that's its mass number. If we look on the periodic table, we see that the atomic number is 6. That also corresponds with the number of protons. And protons equal electrons. Then all we have to do to find the neutron is take the mass number minus the atomic number. So 13 minus 6, and we get 7. So our answer should be 6 protons, 7 neutrons, 6 electrons, atomic number of 6, mass number of 13. Now let's move on to xenon. Xenon has a mass number of 131, so that would go here. We look on the periodic table, and Xe has an atomic number of 54. That also means we have 54 protons and 54 electrons. To find the neutrons, we take 131 minus 54, and we get 77. So our answer is 54, 77, 54, 54, and 131. Now for sodium, we look on the periodic table. Sodium has an atomic number of 11. It's a mass number of 24. It's written right here. That also tells us we have our atomic number, so we have 11 protons and 11 electrons. And all we have to do to find neutrons is 24 minus 11. Our answer should be 11, 13, 11, 11, and 24. And the last one for oxygen. Oxygen has a mass number of 15, goes right here. Has an atomic number of 8, which tells us our protons and our electrons. And then we go 15 minus 8 to get our neutrons. So our answer should be 8, 7, 8, 8, and 15. Now, let's go ahead and move on to some other examples. And we see that we have examples here written in nuclear symbol notation. Now, what we're going to do here is we're going to give it a little bit of a twist. What we're going to do is we're going to look at ions. Now, ions are not neutrally charged atoms. They are atoms that have a charge, okay, either a positive charge or a negative charge. So, to know how many electrons we have, because remember, we cannot change the protons, so to get a charge, we change the electrons. To figure out how many electrons we have, we just do the opposite the sign to the atomic number to get the number of electrons. So for lithium, very first one, we're going to say that it has a charge of +1. Okay, so we can look at this and we know that the mass number's on top, the atomic number's on bottom. So we would have 8, it's the mass number, 3 for the atomic number, which that's the number of protons. In the neutrons, we would have 8 minus 3, which would give us 5. And for the electrons, we do the opposite the charge. So the opposite of +1 is -1 to the atomic number. So 3 minus 1 is 2. Sodium, let's just do sodium as a regular atom. It's neutral. Now, remember that in an ion, it has to tell you that it is an ion. You can't just make it up. Okay? In a question on the test, it would tell you that it was an ion. It would tell you by putting that +1. So since sodium doesn't have a +1 or anything beside it, it's neutral. So now we can just plug it in like normal. Our Mass number is going to be 22. Atomic number is 11. That means we have 11 protons, 11 electrons, and then 22 minus 11 gives us 11 for the neutrons. Now for beryllium, beryllium is going to have a plus 2. Okay? It's got a positive 2 charge. We're going to pretend that this was already there. Now, to figure out the mass number, we know that that's 8. We know that the atomic number is 4. And we know that the number of protons is 4. Now to find the neutrons, we go 8 minus 4, which gives us 4 neutrons. Now, our electrons, since we have a plus 2 right here, we do the opposite of the charge to the atomic number. 4 minus 2 gives us 2. And lastly, we have iron. And we're just going to do this normal. So it's a neutral atom. So we know that we have 56 as our mass number, 26 as our atomic number. That means we have 26 protons and 26 electrons. And then we have 30 neutrons, because 56 minus 26 is 30.